Good morning to you all, good afternoon to you all, good evening, depending on your locality, depending on where you're watching this from. My name is Teacher Mlenga, and as usual, every now and then I make few videos, and trying to help students who are maybe struggling in understanding one or two things in chemistry, in math, and a little bit of physics. You won't find my details. They are right in the description of this video on YouTube. You find me on Facebook. So I can't say much. Let me save time for the presentation. Today is being the 31st, sorry, not 21st, 31st of May, of March 2024. I have a video that I'm going to make. I have a presentation that I'm going to make. And this presentation is based on chemical bonding. So the objectives for today, depending on the time that we're going to have, but presumptively, at the end of this lesson, students who watch this video should be able to define chemical bonding, should be able to explain why atoms form bonding. That objective also is in between the lines. Should also able to list the type of bonding that are present, if at all elements form bonding, atoms form bonding, in how many categories can we put? And thereafter, I should be able to discuss how these atoms form bonding. Bonding, atomic structure, and the periodic table, these are threshold concepts that are very, very important in our chemical fraternity. Most of the time, students struggle in chemistry. It is because they lack these basic concepts. They are a concrete foundation in our chemistry journey. However, without wasting much of the time, that was just the introduction. Let us get started. So, how do we define chemical bonding? Every now and then I'll be sourcing for information from external sources so that we link to the discussion that we're having today. So how do we define chemical bonding? And then thereafter, the video is made as I upload this video on YouTube. I'm also going to upload this I'm going to upload this document in the description of the video. So how can we define chemical bonding? Before we go to the description of chemical bonding, let's run it through. Let's have some chemical fun. Let's look at certain elements. The first element that we're going to discuss, maybe let this be part of the video, consider the following elements. I'll put 4 elements across that we're going to consider. Element number 1, let's consider lithium. Lithium, we have to understand that the symbol is Li. The atomic key number, which is represented by Z, is equal to 3. The mass number represented by A is equal to, it has got 7. So if we are to write the configuration, the electronic configuration of this lithium element, how will the configuration be? According to different scientific or chemical models that have been introduced to the science that we have, not advanced chemistry, not IBDP of chemistry, not A levels, I'm just looking at basic science. It is suggested that the first shell gets 2 electrons. The maximum other than the first shell is 8. But believe you me, some elements do not have shells that are fully occupied with electrons. Some have less, And of course, there are those that have got full shells with electrons. So how many electrons do we have? We have 3. We have just used the 2. And therefore, how many are remaining? We are remaining with 1. Now, this one here, we are saying that the maximum must be 8. And yet, it only has 1. Therefore, this element is in trouble because the electrons in the outermost shells are not fully occupied. The shells are not fully occupied. They are supposed to be 8. And therefore, this element has the tendency, the ability, the capability that this element has to make sure that the last shell is fully occupied. And as a result, this element has the ability to interact with another atom so that the number of electrons in the outermost shells must be 8 at all cost. I'm trying to introduce you to chemical bonding, the ability, the tendency that atoms have in order to interact with other elements. So this lithium is got to decide. The maximum that should have is 8. It's got to decide. Because it has 1, either it has to lose 1 electron or it gains how many? Or it gains, or it has to lose, it loses 1 electron, or it gains 7 electrons. Now, come on, guys, this is common sense. What likelihood do you think that we should have? Either for this lithium to lose 7 of them or to gain 7 of them, so that once we add to this one, they get to be 8. Come on, guys, this is no-go area. The likelihood that it has is that lithium should lose 1 electron, and when it loses, it will only remain with the first shell with 2 electrons, and therefore it's going to be stable. Remember, I said we're going to look at 3 elements, and that is the first element, lithium. The second element that we can look at, I hope that sinks in your mind, that lithium is going to 1 electron in the outermost shell, so it's either gains 7 electrons or it loses 1. But the likelihood is that it loses 1, so that it remains with only 2 electrons in the first shell, and there it makes it to attain stability. Let's move on. Let's go to another one. This other one is carbon. I said we only look at 4. Carbon. Carbon. Now this carbon, the symbol is capital C without wasting much of the time. What else? The atomic number is 6, and the mass number is the mass number is 12. The electron configuration, how will we place these electrons in the outermost shells? How will we place them in the outermost shells? There are 6, of course. So the first shell will get 2. Now, because there are 6, the last shell will have only 4. Now, what does it mean? The last shell should have 8. It's got 4. So meaning it either it loses 4 electrons that it already has, or what can happen, or is that it gains 4 electrons. Now let's bet. Where do you think we have good likelihood? Is it gaining 4 electrons? Is it losing 4 electrons? The chances are equal. The chances are equal. As a result, this element cannot lose, at most cannot gain, in most cases, something else has to happen to it. I want you to pay attention to this. The first one, we picked on losing because it has got few. than what it can gain. Here, they are equal, so the chances are the same. Let's look at the second last, which is the third one. We're going to look at fluorine. Let me just look at chlorine. Chlorine, the symbol is capital C and a small l. Likewise, the atomic number is 17 and the mass number is 35.5. How do we do the configuration? How do we write the electronic key configuration? How do we do it? So the electronic configuration will be like this. Because there are 17, so the first shell gets 2. The second shell gets 8. Oh, wow, that's a lot. Together, so far, we have used 10. These ones are 10. But there are 17. How many are remaining in the last shell? You can pause and guess. There's 7. And therefore, these 7 electrons are very, very important. And if you look at what we are looking at, we are considering the number of electrons in the outermost shells. Very important. And because of that, let's look at the likelihood. It is either this element loses 7 electrons. Come on, that's a big joke. Or it gains 1 electron. Now, where do you think there are more chances? This element to lose 7, that's a lot. Or this element to gain 1, buddy, will pick on this. It's easier for you to give out a coin that you have than going round picking 7 coins from, let's say someone donates 7 electrons, 7 coins, and you only giving out 1. You see, the person who's giving out 7 electrons will have deep pain experienced because what is lost is more than you who has just gained a single electron. So that is what we are talking about right here. So these guys are likely to lose. The first ones lose. The in between, share. So that nobody loses, nobody gains, they share. And then the last one will definitely gain a single electron. We look at the last one. The last one is going to be a little bit easier, and that last one is helium. So helium, or maybe let's pick on a different one. Let me take you to the periodic table, and then we look at, oh, this thing was loading again. I thought I downloaded it all. Too bad. I wanted to pick on the periodic table so that you look at the element that I was picking. I was picking on neon, which has got 10 electrons. Allow me to minimize this, and then I maximize this. So we're going to pick on neon. We're picking on neon. So this neon, let's write it here. Let's replace it with helium. Let's pick on neon moon. I love that song. So neon, the symbol is capital A in the first letter and the second letter. Now let's go, buddy. The atomic number on your own, you can check. The atomic number is 10. And the mass number is double, which is 20. Now, if we are to write the electronic configuration, how best can we do it? Let's just type it. So configuration is something. Okay. Configuration. Okay, let's go back here and do the configuration. Too bad. Configuration. How do we write the electron configuration, buddy? So we're going to say that the first shell gets 2. There are 10. The last shell gets 8. So already we are saying either it loses 8 of them, or it gains Nothing. Where do you think chances are lying? This element to lose 8 of them, so that maybe we talk about this at the first show to have 2 electrons, that's a maximum, or it gains nothing. Believe you me, if I was this element, I would opt for gaining nothing, so that I remain where they are. So these are very important concepts that we have to talk about. In summary of this presentation, these elements that are here, and among the few that I'm going to itemize, they lose electron. And these ones that we have here, believe you me, these guys here, they do not, in short, what they do is they share electrons. In most cases, they share electrons. What about chlorine and others? These guys actually, what they do, they gain electrons. They can't lose. So in most cases, they gain, or they also do what? They share. Then neon, all those elements that are on the far right of the periodic table, those guys, they do nothing. As a result, they are said to be stable and don't take part in any chemical equation. Now let's give the summary. Just give me a second. Okay, now let's give the summary. Are these the only elements that we can talk about? Is this the only representation that we can have? Nay. So let's go to the next slide. So, grouping of elements. How do we do the grouping? I hope you guys are following, because this is very important as the backbone of chemistry. So if any element has valency electrons, we know what the valence electrons are? Electrons in the outermost shells. How many electrons? This is now the generalization of atoms. If an element has valence electrons, the number of electrons, let me say electrons in the outermost shells, how many should they be? Number A, 1 electron. Those that are in group 1. Group 1. 2 electrons. Those that are in group 2. And 3 electrons. Those that are in group 3. What would you say? Always these guys, for as long as they've taken part in any chemical reaction, always they lose the electrons. Not just any electrons, they lose the electrons that are in the outermost shells. So they lose the outermost shell electrons. Can I say that? They lose their outer shell electrons. We have to pay extra attention to this. They do lose them. Out shell electrons. They lose them. Very important. And because of that, it will take us to, or it will bring us to a specific type of bonding. Remember, one of the objectives that we should be able to classify the bonding that these guys form. So all those are in group 1, those are in group 2, those are in group 3, those are in group 4. We're talking about those major groups. They lose electrons. That's one thing. Maybe let me put it in bullets. 1, they lose electrons. They lose electrons. What else do? they also become positively charged. Positively charged. The previous video I explained how these charges are attained. What else do? Because of this, they are considered to be metals. They are considered to be metals. Very important. So all the elements are in group 1, those are in group 2, those are in group 3, they lose the outermost shells. These electrons, these are the ones that are causing them to belong to a particular group. So if it's in group 3, it has to lose 3 electrons. If it is in group 2, it has to lose 2 electrons. If it's in group 1, it has to lose the very electron. And the size of the charge depends on the number of electrons lost. In that, if an element loses 1 electron, its charge will be positive. If it loses 2, it is going to be 2 plus. If it loses 3, it's going to be 3 plus. Let's move on. We go to now elements that are in other groups. Elements that are in the other groups. So if an element has got 4 electrons in the outermost shell, if an element has got 4 electrons in the outermost shell, these guys do not gain. Should I just say they neither, they put in bracket, they neither gain, always, they neither gain nor share. No, they neither gain nor lose, but only share their electrons. How many electrons do they share? 4 of them. They do share if they are reacting with the very element. But if they are reacting with the different elements of different abilities, of course, 4 of them will be shared, but not 4 of them at a go. They split, maybe 2 shared here, 2 shared here, or maybe 1 shared here, 1, just like that. Depends on the element that it is sharing with. And because of this, it's not a metal, it's not a non-metal. The simple name that we give to them are metalloids. They are metalloids. Very important. I want this to stick in your mind. Then the third, we're going the same procedure. Remember, I picked on group 1, but here now it's a general all the way up to group 3. 4, there is nothing else that we can do. It's 4. Therefore, we'll go to 5. So if an element has got 5 electrons in the outermost shell, meaning it's in group 5, it's got 6 electrons in the outermost shell belonging to group 6. And if it has got 7 electrons in the outermost shell, it's got 7 electrons in the outermost shell, making it to belong to group 7. But what would we say about these guys? These guys are ruthless. These guys are ruthless. And then what would we say? These guys gain electrons in most cases. But if they can't gain electrons, then it's better they share. But they will never lose. They never loses electrons under normal circumstance. So group 3, such as group 5, such as nitrogen, group 6, such as oxygen and sulfur, group 7, such as chlorine, iodine, bromine, fluorine. These guys, they do not share, they do not gain, they can only share, and they can never lose. They can only share and gain. And how many can they gain electrons? They can only gain how many? 3. No, 1, because they already have 7, meaning they only need 1 electron in the outermost shell. I hope that makes sense. And if they are to share, what happens? They only share 1 electron. So they will donate 1 in the sharing, and they also get to share with 1 from the other element. They only share 1 electron. They only share 1 electron. So meaning, there are 7, let's remain with 6. 6. The 7th one is shared with the other one. Then the other one also brings another one for sharing. So there will be 2 that are shared, plus those 6 that are inside. Together they're 8, which makes it stable. Then the last one are those that belong to a particular class of elements. Those that have, if the first shell is 2. If the first shell gets 2 and they are the only elements that are there, and the example is helium, you can do the configuration on your own. Or if there are 8 electrons in the outermost shell, 8, and they are the last ones. These guys are very stable. Because they are stable, they don't share, they don't gain, neither do they lose. They can't do that. They're very stable. And in life, those that are said to be stable are the ones that live in misery. Because they think they have it all, they can't, they even think we can survive without others, but others cannot survive without us. Believe you me, when life strangles them to their knees, they go down begging, even low class ranked people. Many a times you look down on landscapers, garden boys, maids, general cleaners, and all those people are very important in life, because without them, their jobs that they do, it's us could have been doing that job. So everyone in life is very important. Let's treat them equally. Let's give them the respect that they deserve. Okay, end of commercial break. So those are very, very, very important backgrounds. And now, because we are saying that, because you're saying that they lose electrons, and when saying they gain electrons, those are in category number C. They are not metals. They are non-metals, and they get, or they attain, a negative charge. So these guys, when they are done with gaining of electrons, they attain a negative charge. What about when they share? When they share, there is no charge that is put on them. So they attain a negative charge when they gain electrons, not when they are shared. When electrons are shared, there is no charge, because those electrons do not belong to any of the elements present in the sharing, but they are for every element there. Therefore, there is no one who is honored in any way. Very important. Very, very important. These are a prerequisite information for bonding. Then let's define it. Because we are saying that these that do not have outermost shells fully occupied, they form bonding. So remember that point number 1, all the elements with electrons, with last shells, with outermost shells that are not fully occupied, all the elements with outermost shells that are not fully occupied, what do? They react with the other elements. They react with other elements. That's one thing you need to remember. Why do they react with other elements? Because they are not stable. So stability of atoms depends on, one of the ways is that they depend on the number of electrons in the outermost shells. They react with other elements. They are not very stable. By reacting with other elements, what do they say? They form bonding. So they form bonding because they are not very stable. So stability is what causes elements to form bonding. Stability of element is what causes them to form bonding. So what would you say? What is bonding? What is bonding? What is chemical bonding? How would you define chemical bonding? So in simpler terms, we can pause for a while and try to define your own way. So we can say that this is the combining. Should we say the combining, or this is the interaction of atoms in, this is just just interaction of atoms. In simpler terms, we may define it in that way. Bonding is the interaction of atoms. Is the interaction of atoms. Why is this interaction important? So we are saying that atoms form bonding in order. Why do atoms form bonding? Let's look at reasons. If it wasn't important, then these atoms wouldn't have been taking part in chemical reactions. So atoms form bonding in various ways. One of the ways, in order for them to be stable. One, stability is very important. Even in life, come on, people find life partners so that they are stable. There are certain things when you are single. I, for one, now single, I spend money in a very uncontrollable way. I wasn't drinking, I wasn't going out in many bad ways. I just did not have anybody I was considering as being part of my money. So I would spend it, I'll get paid. The other money is coming. But when you settle down with a woman, when you marry, believe you me, you become responsible. You are stable. Any money that you have in your pocket, be like, I think, oh my, if I can do this and that, maybe I can even save for the future use. Because you have somebody that you're considering as part of you. So atoms also form bonding in order for them to be stable. And the stability comes in when the last shells are fully occupied. In order for them to be stable, as the reason number one. What else? In order for them to attain octet stability. Now, I just decided to separate these two because maybe we can understand it better, but they are just the same, octet stability. Octet, it's a rule, octet rule, I might have spelled it wrongly. Octet rule, there's a rule that brings us to a better understanding of the stability of atoms. It's a bit of advanced chemistry, but we are also going to understand it a little bit in one way or the other. So atoms, why do atoms form bonding? In order for them to be stable, in order for them to attain octet stability. There are many reasons, but those two are the ones that we're going to consider. Okay, we can move on to now types of bonding. So now, the types of bonding depend on the elements that are taking part in a chemical reaction. So you have to remember those 4 classes that we talked about, group 1, 2, and 3 alone, group 4 alone, 5, 6, 7 alone, group 8, or those that are called group 0, also alone. So let's look at the types of chemical bonding. So if I may wish to inform you, I better say that, unfortunately, I cannot use shortcuts to put some few things on these things, so board and that. Okay, I have to remind you that the type of bonding, the type of bonding that atoms form depend on what do they depend on? One, the nature of the elements present. The nature, is it a metal? Is it a non-metal? Is it a non-metal or is it a metalloid? So the nature of the element will dictate the type of bonding that is likely to be there. And because of that, we are saying that metals can only take part in two types of bonding, which we are going to look at. Non-metals can also take part in two types of bonding. Metalloids can also take part in no, metalloids is just one. So yeah, let's classify. So metals, two types of bonding. Non-metals, the two types of bonding, and then the metalloids on one. So one, the nature of the elements present. Being the nature of elements will determine either electrons. So the other ways in which the type of bonding depend on is with either electrons are gained, lost, or even shared. So if electrons are gained, now of course gaining and losing, these are the same, because when one loses, the other one must gain. When one loses, of course, the other one must gain. So it's either electrons are gained or lost, or electrons are shared. Then we will tell the type of bonding. So now, which ones are these? Which ones are these? Number one, the type of bonding. The type of bonding is what is called ionic bonding. Now, when you hear of the word ionic bonding, ionic equations, this involves the gaining and losing of electrons. So in chemical bonding, in the chemical bonding type, the first one, that is ionic bonding, this type of bonding will say that it involves gaining and losing of electrons. That is the first one. So we are saying that it involves gaining and losing of electrons. That's the first type. So meaning this type of bonding, remember the ones that are losing are metals. So it happens between the ones that are losing are metals with number of electrons 1, 2, or 3. That's why I started from there, so that we get reminded at this point where we are. Ionic bonding involves the gaining and losing of electrons. Now, which ones gain electrons? Or rather, which one lose electrons are metals, and these metals have got electrons with number of electrons 1, 2, or 3. So it's between metals and the non-metals. What do we say about non-metals? They've got electrons 3, 5, rather, 6, and 7. So in a moment, now let me pause here for a while. In a moment where you have the chemical bonding taking place between an element whose number of electrons is 1, with an element whose number of electrons is either 7, 6, or 5, do not go very far. Just know that the type of bonding that is taking place is called ionic bonding, because one is a metal, the other one is a non-metal. Not only that, because the one which is termed as a metal is going to lose electrons. The other one termed as a non-metal is going to gain electrons. As a result, there is going to be ions that will be formed. Okay, so the other point that we can say is that the other point that we can say about non-metals is that it involves the formation of ions. Now, you know what the ions are there? We're talking about positively charged ions as well as the negatively charged ions. So these charges are formed at the same time. So these with electrons in the outermost shells is 1, is 2, is 3. Remember the previous discussion? They will form a positive charge. These ones, electron in the outermost shells, 5, 6, and 7, they will form a negative charges. And these are the ones that are called ions. That's why this type of bonding is called ionic bonding. So the compound that we form when an ionic bonding takes place, we expect that to have both the charges, the positive charges as well as negative charges, and the positive charges are coming from metals, negative charges are coming from non-metals. We look at the other one which is called covalent bonding. Covalent bonding, which is called, so we're still talking about types of bonding, and the third last is called covalent bonding. So this covalent bonding, yeah, it is simple, guys. It's quite simple. It, okay, I can say is a type of bonding that the type of bonding that takes place among non-metals. So in the covalent bonding, we only need non-metals. And what are these non-metals? They are the ones with electrons in the outermost shells. Now remember I said that even those with 4 electrons, it's either they share electrons or they share. That's one thing they do. It's either they share or they share. So because the sharing, and remember also sharing is part of the type of scenario that happens with non-metals, therefore we're going to classify them. So starting from group 4 elements, they are able to take part in this type of bonding. What name is given to it? Oh, I just forgot. This is called covalent bonding. So covalent bonding, the type of bonding that takes place among non-metals, those elements with electrons in the outermost shell, 4, 5, 6, and 7. So among themselves, they are able to form covalent bonding. Group 6 and group 6, they're able to bond among themselves. Group 7 and group, they are able to bond among themselves. However, here we are going to talk like matured people. We'll say as well as hydrogen. So hydrogen can take part in both ionic bonding, can also take part in both covalent bonding. The question is why? Isn't it very confusing? No. When you look at the configuration of hydrogen, atomic mass 1, molar mass 1, the configuration is 1. And we are saying the first shell should have 2. So hydrogen also is in dilemma of either gaining 1 electron or losing one electron. So hydrogen actually does both. It can gain electrons, it can lose electrons, or even share. Though in most cases, the tendency of hydrogen gaining is minimal for reasons we're going to discuss ahead. So it's either it loses or it shares. And because the sharing is part of what hydrogen is also expected, that's why we have made an inclusion of hydrogen here. Now, that is very clear. So that's very clear, very clear. Now, what else do we know about covalent bonding? Is a type of bonding that involves the sharing of electrons. They involve the sharing of electrons because sharing of electrons is what is common for these guys. It's either they gain or they share. So if they are among themselves, there's no one who is donating. They cannot receive. As a result, they will just share. So this is a type of bonding. Examples, we'll look at them as we go further. But for now, that is very important. Then the other one is called, new slide. The other one is called metallic bonding. Metallic bonding. Now, we also have to go back just some few steps backward and look at this. Remember when we were talking about, just today, about group 1, group 2, as well as group 3 elements. These elements, if we are to draw a model, just allow me to come up with a model like this. Let me say for an element such as lithium, I73. So the first shell, of course, is likely to have 2 electrons. Let me just put up the first shell here. And the electrons, we are going to distribute them. So electrons, the first shell will have 1, will have 2. Maybe let me use a different color. Let me use a different color so that we understand better. So the first shell will have 2, 1 here and 2 there. It's okay. Then the second, there are 3, we have used 2. Therefore, only 1 remains. But how many more spaces do we have where hydrogen can sit? We actually have a lot. So here we expect 1 electron. Here we expect 2. Here we expect 2. Here we expect 3. So how many more do we expect? 7. But yet there's only 1 electron. As a result, this electron is said to be delocalized. When we say delocalized, something that is local is just meant to be there. It doesn't experience the enjoyment of life from the other side because they are localized. But when you say delocalized, meaning they are able to explore the other environments. So these electrons that are there in elements with 1 electron in the outermost shell, 2 electrons in the outermost shells, as well as 3, they are said to be delocalized. So this delocalized electron is able to move about, it's able to move about, it's able to move about, it's able to move about. And then not only that, because these are metals, they also have positive charges in their metal lattice. They also have positive charges in their metal lattice, and these positive charges are protons. So the metallic bonding is a type of bonding that exist between delocalized electrons as well as positive charges in their metal lattice. So maybe I can write that. So this type of, so again say that this is the type of bonding that exists between the delocalized electrons and the positive charges in their metal lattice. So this is what is called metallic bonding. Metallic bonding, right from the name metallic, they are a type of bonding that takes place between metals. So they are a type of bonding that occurs among the atoms of the same element. Now here there's an exception. We cannot say those elements that are in group 2, calcium, and those that are in group 1, lithium, as those two atoms coming together to form a metallic bonding. No. We're talking about atoms of the same type, carbon, if it's a metal, iron, zinc, lithium, atoms of the same elements that are having the force of attraction between the positively charged ions as well as delocalized electrons. That's what we are calling metallic bonding. Maybe let me include it in there. It's a type of bonding that exists as a result of the forces. It's a type of bonding that exists as a result of the forces between the delocalized electrons, which are negatively charged, as well as positively charges that are in their metal lattice. So this is where we can end today. Few moments later, we are going to look at how does now this bonding take place. So let's go back to our objectives. Are we able to define the chemical bonding? Yes, we did. Have we explained why atoms form bonding? Yes, we have. Have we listed the types of bonding? Yes, we have. Therefore, the only one that is remaining is to discuss how the action, you explain everything, how does it happen? Believe you me, friends, now I'm going again, I have to take you back that this type of a lesson is very important because it is a background for many of the lessons that are to come. So in case you've got questions, you can reach me on YouTube, Teacher Mlenga. You can reach me on Facebook, Teacher Mlenga, and my phone number is +260975578 or you can reach me on my alternative number +2609535888079. See you in the next video. Carbon.